Problem number 15. Consider a vector value function r of t is 3 cosine t, 4t, and 3 sine t. So the first thing we have to do is sketch r of t on a set of axes here, x, y, and z. And so the thing to realize is that 3 cosine t, 3 sine t, that's making a circle in the xz plane, while 4t, the y coordinate is increasing. And so what's happening here is that this is going to be a helix, and it's going to be a helix that is spiraling around the y-axis. So let's see here. It should look something like this. So helix that is spiraling along the y-axis. If you slice it, if you were to take slices, if you project everything down to the xz plane, you see a circle, but the 4t things are increasing in the y direction. Part B asks us, is this an arc length parametrization? Why or why not? And so arc length parametrization, the definition of that is when the speed is always equal to 1. Let's determine this. If we take the derivative, r prime of t, we would get negative 3 sine t, 4, and 3 cosine t. So the magnitude of this is the square root of negative 3 sine t squared plus 4 squared plus 3 cosine t quantity squared. And so we have 9 sine squared t plus 9 cosine squared t plus 16. 9 sine squared t plus 9 cosine squared t is just 9. 9 plus 16 is 25. Square root of 25 is 5. This is not equal to 1. So this is not an arc length parametrization. Not an arc length parametrization. However, the fact that the arc length is such a simple expression does mean that we can do calculations very quickly. So in part C, when we were asked to find the arc length of r of t between 2 and 9, the arc length formula is just the integral from 2 to 9 of the speed here, 5 dt. And so this is just 5 times 7 is 35. Because to find the arc length, you integrate the magnitude of r prime of t. And the magnitude of r prime of t is 5. And then finally, we're asked to find an equation for the tangent line to the graph of r of t at time t is equal to pi. So for that, we need r of pi and r prime of pi. R of pi is, plug in pi, 3 cosine pi is negative 1, so negative 3, 4 pi, and 3 times sine pi is 0. Then we plug in pi into r prime right here, and we get 0 for 3 times cosine pi is negative 3. And so using this information here, L of t is going to be the initial point, negative 3, 4 pi, and 0, plus t times 0 for negative 3, the direction vector. So that's how you do problem 15.